There are at least 7 different ways space can kill you. Only one of them is fast. If you don't want to miss the next one, hit subscribe. No pressure though, unlike space. Let's start with the one everyone gets wrong. You will not explode. That's a movie myth, and it's a persistent one. Your skin, your blood vessels, and your connective tissue are strong enough to hold your body together against the pressure difference between your insides and the vacuum outside. What actually happens is stranger and honestly more specific. The air already in your lungs expands rapidly and forces its way out. If your instinct is to hold your breath, that instinct will kill you faster because your lungs will rupture instead of simply emptying. Within about 10 seconds, the oxygen in your blood runs out and you lose consciousness. Around the same time, any exposed moisture, the water on your tongue, in your eyes, on the surface of your skin begins to boil. Not because it's hot, because there's no pressure left to keep it in liquid form. This is called ebullism, and it's one of the strangest things the human body can experience. You have roughly 90 seconds before the lack of oxygen causes permanent brain damage. Rescue after that point doesn't bring you back, it just brings back the body. That's the vacuum of open space, with nothing around you at all. Somewhere with actual ground under your feet is not much better. Take the moon. You've still got the same vacuum problem, since the moon has no meaningful atmosphere to speak of. But now add a temperature swing of nearly 300 degrees Celsius between direct sunlight and total shadow, sometimes within the same crater. Lunar dust, called regolith, is jagged on a microscopic level because there's no wind or water on the moon to smooth it down, the way erosion does on Earth. It's sharp enough to work its way into a suit's joints and slowly cut through the seals. And a small puncture on the moon kills you exactly the way open space does, just with extra steps. It doesn't need anything exotic to end you, it just needs one seal to fail at the wrong moment. And Apollo-era engineers spent an enormous amount of effort making sure that didn't happen. Mars sounds safer because it actually has an atmosphere. It isn't safer, it just kills you more slowly. The atmosphere on Mars is real, but it's under 1% the pressure of Earth's atmosphere at sea level. That's nowhere near enough to stop your blood and other fluids from boiling the same way they would in a true vacuum. Layer on top of that an atmosphere that's almost entirely unbreathable carbon dioxide, nighttime temperatures that can drop to minus 125 degrees Celsius, and dust storms so large they've been known to bury the entire planet's sky for months at a time. Mars doesn't kill you all at once, the way open space does. It kills you one failed system at a time. A cracked seal here, a heater that fails there, a dust storm that blocks solar panels for long enough to drain your backup power. Every single habitat and suit designed for Mars exists specifically to prevent that slow accumulation of small failures. Now go further out, past anything with a surface at all, and the rules stop making sense entirely. Near a black hole, everything depends on one variable, and that variable is size. Get close to a stellar mass black hole, one formed from a collapsed star, and the difference in gravitational pull between your head and your feet becomes so extreme that you're stretched apart before you even reach the event horizon. Astronomers actually call this spaghettification, and it is exactly as literal and unpleasant as it sounds. But get close to a supermassive black hole instead, the kind that sits at the center of galaxies like our own, and the math flips completely. Because the object is so much larger, the gravity gradient near its edge is actually gentle. You could, in theory, cross the event horizon alive, conscious, and completely unaware that anything unusual had happened, right up until it had. You don't even need to get anywhere near something as dramatic as a black hole for space to end you. Deep space radiation alone will do the job, with no vacuum or extreme temperature required. Earth's magnetic field deflects the vast majority of cosmic radiation before it ever reaches the surface, which is part of why life here was able to exist in the first place. Astronauts on the International Space Station are still mostly inside that protective bubble, so their exposure, while elevated, is manageable. Leave that bubble entirely. On a long trip to Mars, for example, an unshielded exposure over months will damage your DNA and your central nervous system in ways that accumulate. Long enough exposure causes radiation sickness on its own, no decompression or temperature extreme required at all, and sometimes sometimes you don't even need to leave the ship for space to find a way in. Fire behaves differently and worse in microgravity because heat doesn't rise the way it does on Earth, and smoke doesn't clear the way it does on Earth. Instead, it spreads outward in every direction and lingers in the air. A hull breach, even a small one, pulls breathable air out through the opening within seconds, faster than most crews could react. A failed carbon dioxide scrubber is a quieter threat because rising CO2 levels cause confusion and impaired judgment before they cause obvious symptoms, which means the exact system you'd need to fix the problem is often the first thing to fail. So that's every way. The vacuum of open space, the moon, Mars, a black hole in either of its two very different forms, radiation that needs no vacuum at all, and finally your own spacecraft turning against you from the inside. None of it is personal. Space isn't hostile because it hates you. It simply wasn't built with a human being in mind. Earth was.